In this video, I'll be showing you how to use the discriminant, this vocabulary word, discriminant, to determine the number of solution and the type of solution that a quadratic equation has. So here is a quadratic equation: 2x squared plus 5x minus 2 equals 0. So if I apply the quadratic formula, if you recall, the quadratic formula is this. Okay, so if we apply this formula, where we can actually first of all determine the coefficients. So A in this situation will be -2, B is 5, the coefficient of x, and C is the number that stands alone, the constant, so -2. So we're going to apply this. We're going to apply this coefficient to this formula. So I'll write that x equals -5. Remember to always use parentheses to plug in your values. So I'm going to go ahead and write this as parentheses. My A is -2 and my C is also -2. So now we have that set up. So the next thing we're going to do is to divided by 2a, 2 times -2. All right. So now we're going to simplify this a little bit further. So -5, -5 is just -5. So plus minus square root divided by some number -4. Okay, now we're going to look for what is supposed to be inside that square root symbol, the radicand. So let's try to simplify the number, the expression. So we have 5 squared minus 4 times -2 times -2 again. So that is the stuff inside there that I'm going to try to simplify. So what I would do is I will use the PEMDAS, so order of operation. So first we will do the exponent. So this will be 25, and then minus. We're going to leave the minus we have multiplication to do before we do minus. So we're going to multiply 4 times 2. -2 is -8, and -8 times -2 will give me 16. So it will give me 16. So 4 times -2 is -8. -8 times this will give me 16. So we're going to do 25 minus 16, and that will be 9. So the radicand is actually 9. What's 9 there? Okay, so since our goal is to find out the number of solutions and what type of solutions that this will have, well, we can first of all let's just finish finding the values in the solutions first. Okay, we'll see what happens. So -5 plus or minus 3, because square root of 9 is 3, and then divided by -4. So we're going to do this in parts. So we're going to do -5 plus 3, and that will give me -2. So the first answer is x equals -2 divided by -4, or we do -5 minus 3, that's -8 divided by -4. So there are two answers. This will be 1/2. -2 divided by -4 is 1/2, and then -8 divided by -4 is 2. So there are two solutions. Okay, so I just wanted to point your attention to the fact that the radicand, the expression inside under the square root, is the same as this 9 here, which is a positive number. That number is positive. So we must necessarily take the square root of that number and then do plus minus of that. So that means we're going to have two solutions whenever we have a positive number inside the square root there. That will lead us to two solutions, and the solution will be real because the square root of a positive number is a positive number. It doesn't give us imaginary, so it will be a real number. So square root of a positive number is real. So the two answers we have actually are real. The two solutions are real. So in this case, I'm just going to say we have two real solutions. Two real solutions. Two real solutions. All right. Bear that in mind as we look at the next example. In this next example, well, we're going to use the quadratic formula, but this is not ready yet. We have to write this in the standard form. In the standard form, it looks like this: ax squared plus bx plus c equals 0. The right side is a 0, so we must subtract 3 from both sides and write what is left. So we negative 3x squared plus 6x minus 3 equals 0. So now we're ready to apply the formula. So I'm going to start off with the formula like x equals, now negative b will be negative 6 plus minus square root b squared will be 6 squared minus 4 times a, negative 3, and c is also negative 3. So now all over 2 times a, 2 times negative 3. So let's see what happens here. So x equals, now I'm going to do the outside and evaluate the expression inside the square root. So it will be negative 6 plus minus square root of one number coming up there, and the denominator is negative 6. So let's do what's inside the square root. That's a 6 there. So we're going to do that. So we'll do it here. So it's negative 6 squared is 36. Okay, 36 minus, and then negative 4 times negative 3. This is what I was doing. Negative 4. I mean, not negative 4. I'm saying 4 times negative 3. That is negative 12. Negative 12 times 3. That is 36. So 36 minus 36. And that's going to be 0. So it's a 0 coming inside there. Now, what we can do is just to observe that the square root of 0 is 0, so that quantity is gone. So, and the plus or minus 2 doesn't matter anymore because there's nothing to add to, there's nothing to subtract from. So we're just going to say the final answer is negative 6. The numerator is just negative 6, and the denominator is negative 6. And then when you divide negative 6 by negative 6, you get 1. That is only one solution we have. So if the inside is 0, inside of the square root is 0, it disappears. We end up with one solution. So one real solution. One real solution. Okay, bear that in mind. We're going to come back to that. And now we go to another example. As before, we need to rewrite this so that it's going to be in standard form. So this is not in standard form yet. So we're going to do minus 2x plus 2 on both sides. Minus 2x plus 2. And then this side is going to cancel. This side will be left with 2x squared minus 2x plus 2 equals 0. Okay, so we have it in standard form. So our a is negative 2, our b is negative 2, and our c is 2. We're going to apply the formula. So we start with x equals negative b. So negative 2 plus minus the square root b squared, that's negative 2 squared, minus 4 times A is negative 2, and C is 2, all over 2 times negative 2. So x equals 2 plus minus 1 single square root is coming up, and then this is negative 4. Now let's evaluate what is inside the square root. So we have negative 2 squared minus 4 times negative 2 times 2. So negative 2 squared is 4, minus 4 times negative 2 is negative 8. Negative 8 times 2 is negative negative 16. Okay, so let's see. Yeah, well, I'm on the right track. So just checking out that okay, so it'll be 16 over here. 16. It's going to turn out to be 16. And now we are going to subtract. So 4 minus 16 is negative 12. Negative 12. So it'll be negative 12 here. And so when we multiply them, see, I saw my mistake right there. A is positive. It doesn't become negative. Sorry about that. A is positive, and that's why A is positive is minus 16. I just found my mistake there. So 4 times 2 is 8, and 8 times 2 is 16. 4 minus 16 is negative 12. Okay, we're in the right order. Now let's move on. So the number inside the square root is actually a negative number. So if you try to take the square root of that, it's going to come out to be imaginary. So we're going to have imaginary number like this. X equals 2 plus minus, the square root of negative 12 is 2i root 3. 2i root 3. If you check out the previous videos on finding the square root of negative numbers, and that's divided by negative 4. So we have imaginary numbers involved. So now we're going to simplify all the way to the end, and that will be we can actually divide everything by 2 there, by negative 2. By negative 2 will be 2, and this negative 1, and then this one becomes 1i over there, but this turns the sign. So x equals negative 1 plus minus I root 3 all divided by 2, which we can separate into 2 as negative 1 plus I root 3 divided by 2, or let's use comma, and the other one will be negative 1 minus I root 3 divided by 2. So here is these two answers are complex solutions. They are complex solutions. So I'm going to write it over here. We have 2 complex solutions in this case. 2 complex solutions. 2 complex solutions. So now we can see that whenever the radicand, the expression under the square root is positive, we have 2 real solutions. If the expression is 0, we have 1 real solution. All right, we have 1 real solution. But if the expression is a negative, we have 2 complex solutions. So we can summarize our findings so far as this. If the discriminant, okay, the expression under the sign is called discriminant. If you go back to the original formula all the way, you see this expression here, b squared minus 4ac, that's called the discriminant. That's called the discriminant. So now let's summarize. If the discriminant is more than 0, that's positive. That means if it's positive, Then you have two real solutions. Okay, just like we found in the first example. As the first example here is positive number 9 is two real solutions. Now, if that expression is exactly equal to 0, we'll have only one real solution. And if that expression is less than 0, like if it's a negative number, then we have two complex solutions. We can actually apply this to other, kind of situations, like if I have x squared minus 3x plus 7 equals 0. If somebody asks me what kind of solution is this going to have and what type, well, I don't need to go through all of this formula anymore. I can just look at the expression under the square root, which is just b squared minus 4ac. I'm going to try to plug in and see if I come out with a negative or positive or 0 and see what happens. So let's try to plug in there. So knowing this, my a is 1, my b is -3, my c is 7. So let's plug into this now. So it will be b squared minus 4ac will be -3 squared minus 4 times 1 times 7. So -3 squared is 9, and 4 times 1 is 4 times 7 is it's 28. So 9 minus 28, that will give me a -19. So -19. So I really don't have to do all of the quadratic formula if I'm only interested in finding the type. So the type and number of solution that this equation will have. So now I can tell you the type. Because it's a negative number here, it's going to have complex solutions. And how many is going to be? It's going to be two complex solutions. Because I'm going to have plus or minus square root just like this. Just like this. It's going to be plus or minus square root of some number that is a negative. And that will give me two complex solutions. This will be the answer to this problem that, say, what kind of solution does it have? And how many? Well, it has two complex solutions because when I did this discriminant, it came out to be a negative number, and so we can say it has two complex solutions. So that's how we do it. And yep, have a good day.